actually meaning to do these tech talks for quite a while now. For the past few months, we've been meaning to start a series of tech talks by computer science faculty, so that all of our students can remain in touch with the latest and greatest in the field of computer science. We have so many expert faculty, such as Dr. Khan in the department, who each has expertise in different areas of computer science, and each one of them can come and talk about their areas of knowledge. So Dr. Khan is going to be our first. He's one of our senior members of our faculty. He has a PhD in computer science and master's and bachelor's in electrical engineering. Dr. Khan is the founder of Internet of Speech. He founded the company in 1998 with the vision to develop innovative technology for accessing information on the internet anytime, anywhere, using just ordinary telephone and human voice. As a pioneer in the internet voice space, Khan is a frequent speaker at natural language, voice recognition, internet applications, bridging the digital and language divides, and other academia and industry conferences and trade shows. He holds 23 patents and has published more than 60 journal and conference papers on the advent of intelligent internet, content rendering, natural language processing and understanding, big data, bioinformatics, software engineering, neural nets, fuzzy logic, intelligent systems, VLSI and optics. So you see, he's quite an expert in quite a wide range of areas. Khan's acute technical knowledge and keen understanding of emerging markets has played an important role in the development of Internet of Speech's key products, services, including NetEco, voice internet that delivers complete internet access via voice and any phone, and SEBLA, semantic engine, using brain-like approach. During his career, Khan invented, defined, developed, and deployed worldwide intelligent software products for microcontroller-based home appliances. He has also created and deployed speech recognition internet applications, and he has 20 years of experience with large semiconductor companies such as Intel and National. And he has also 8 years of experience in academia. He is, like I said, he's one of our senior faculty. He's respected by all the faculty and the students. And I'm going to hand it over to Dr. Khan for today's.
Thank you very much, Dr. Payman, for nice introduction. And thank you very much in advance for coming. I know it's Saturday. Time to relax and enjoy. You have 6-day week, but I'm glad that you are here. Hopefully it will be useful, you will learn something, and you can use it later on and tell your friends about it. With that, let's get started. So, as you can see, our topic is natural language processing, key for next generation, big data and data science. And so the topic is going to be natural language processing, big data, but this topic is very broad, and we need series of lectures. So what I'm going to do in this one, this is the first one, so we're going to do mainly introduction, and then some reasonable details so that you get excited, you get something out of it, right? You took the time to come here. And vision and plan and what we are doing. So that itself should be reasonably good, I hope. Now, you have heard the term big data in newspapers from your friends, students, your colleagues who do big data courses, and so on. Every day, we are generating 2 exabytes. Exa means 10 power 18 from your communication with Facebook, from sensors, from emails, from Twitters, and so on. So lots of data are generated every day. And that's what is called the big data. We just don't know all the the algorithms, all the processing, all the software to make use of this data in an efficient way. When I say make use, we'll go into details. That means, processing, storing, copying, understanding, and so on. And then, while it is difficult to handle big data, it's also an opportunity for us. So challenge brings us opportunity, right? You all came here to study computer science. Why? Because once you graduate, you will have good jobs. And the challenge is, you go through all the difficult courses, right? In a sequential way, quickly, 8 months, 9 months, then you go to the industry and learn more and then take the rest of the courses. So you are working hard to achieve something better, bigger in the future. So we will be looking for this opportunity. Of course, we will address the challenge, but opportunity is something that's going to drive us. On the other hand, you might also have hard data science. Data science and big data, first of all, are very much used interchangeably. So people may sometimes mean that data science means big data means data science. But actually data science is the process and systems needed to extract useful information from the data. And when we say that useful information, that means what does this data mean? How can I use it? How can I improve it in my business? How can I improve it to help our users and the like? And so we also need to automate this because data size is so big, there is no way a human can understand billions, trillions, and exabytes of it. Automation means algorithms, machine learning, and others. And also, data these days are very complex. It's not those simple data like integer or floating point. It's text, numerical data, multimedia data, video, image, audio, all sorts of data. This is a continuation or extension of well-known field like statistics with data mining and so on. When you say data, I just mentioned, I told you mixed data. So data means both structured and unstructured. Quick check, can you hear me well from the back? Yeah, very good. Now, we are familiar with, usually, numerical data. Right? You crunch data, our computer is a very good number cruncher, right? It can do 3 to the power 91 in few seconds, whereas if you give it to me or I give it to you, we need probably a day or two, right? So it's a very good number cruncher, and most of the world has been with number crunching. So data and data science, both of them, big data, have been focusing on this number crunching. I'll go more into that. But today, as you know, data is also dominated by unstructured data like text. You read text on the internet, you get tweets on the phone. These are all natural running text, right? No numbers. And same thing with many other applications. So we'll talk about those. We are including both in this. And then we have both challenges and opportunities that I mentioned on the big data side and also on the data science side. But they are also used interchangeably. So you can use either one. Now, as I mentioned, whatever we do, our goal is to help people at one hand, which is subjective, and then objective, make money, right? You make your own money, company makes their money, and so on, and help the society. So I'm going to give you some perspective from application standpoint. Okay, once you graduate and join the industry, right, you will be actually working on something in this area, depending on which company you join. So it's good to see where we can use So high level is processing challenge standpoint. How do you process, do you analyze, extract meaning, very important. Without meaning data is useless. Analysis, summarization, drawing inference, which today computers cannot easily do. And the next level is common areas, business analytics, where you analyze how did the business do it, or will do in future, what is the trend, and so on. Meteorology, economic, biology, you name it. Today, without computer, we can't do anything, right? The most important computing machine, every area you put. On the other hand, we have popular areas like intelligent information retrieval, which includes intelligent search, question and answer, language translation. So, we started this world with, agriculture, right? We were in agricultural age, then we moved into industrial age, now we are in the information age. As you know, it's a progression, it's not going to stop at information age, right? We have to move forward. What is next? Of course, we know it is the knowledge-based society. Is that the end? No. After that will be intelligence-based. After that will be something more. We can't stop. It's a dynamic system, continuously growing. So this is the key player to drive information age to knowledge-based society. You want to transform. And you are the key driver. You will be the industry leader someday. You will work there. You might form your own companies and so on, right? As I mentioned, we have both subjective and objective here, which is also important from Maharishi's consciousness-based education standpoint, and we are at MAM, so we'll be relating that as well when possible. Now, in moving to the knowledge-based society, I wanted to show you a little bit more so that you know how you are related, what you can contribute, what is your role, what is your challenge, and so on. So we are talking about a huge resource that we have to make from people like you. And data comes, as I say, 2 exabytes come every day. It's increasing, it will be more in the future. Data has no meaning or no usefulness unless we convert it to something. So we need to convert this huge data into knowledge. And you have to write the software, algorithm, system, tools, everything needed for that. And many companies are doing it. After that, somebody has to use that knowledge to understand and take it to the next step. Right? And that's you. That's us, human. Computer cannot do that yet. Then comes, we go to transfer it to other people. You become expert. You have to transfer your knowledge to, for example, to the country that you came from, so that they can benefit more from your knowledge. And this goes on. It's a continuous cycle. And then we take part of it. People form companies and they form product services. Those go to the customer, and customer becomes more knowledgeable, and whole society becomes knowledgeable, and we move into the knowledge-based society. Now look here. Who is controlling all this? Unique intelligence system driven by artificial intelligence, machine learning, natural language processing, data science, big data, data mining, and more. So you are in the driving seat. You are driving the car, and you got to make sure that you drive it right. And that will give you benefits, basically challenges and opportunities. Now we can, with that overall idea, let's look into the details. So problem, searching, transferring, sharing, storing. We are not talking about a small amount, right? Very large amount, very challenging. Analyzing, processing, viewing. Even to view the data, everything has to be done in reasonable time, preferably real time. We are all real time people. You don't want to open a browser and wait 1 minute these days. 15 years ago, you could wait 30 seconds or a minute, but these days, few seconds, then you will get impatient because you got used to it. Deriving meaning and semantics. This is very important, and I'm going to emphasize more on this one because everything we do, especially with text and mixed data, natural language processing, we need the meaning. A simple example. Last 10 minutes I have been talking, you understood, and so on, right? But this machine has been on. Okay? It did not understand anything. If I turn my speech recognition on, it would understand few words probably, pick up, but it will not understand what I have been saying. Why? Because the semantics is not there. There is no meaning to this machine. And that's why computers cannot converse with us. That's what we're trying to do. That's part of this also, part of this chapter. And then summarization. Once computer can understand meaning, it will be able to summarize. Because of the meaning, we can control, understand, we can summarize any article we read. Same thing we can do it inferencing, making predictions, and there are more things, Analytics, for example, is very important. I will talk more about that later. And all these problems are related to 5 V's, which you have heard probably. One is volume, many items, too much data as I mentioned. Velocity, every second coming, right? You take a picture, even instead of taking one picture, you might take 10 of them and send it because it's easy, free, right? But it takes bandwidth. Nothing is really free. Variety of data is picture, audio, video. Variability, there is typos, abbreviation, reliability, is the data correct? So variety of data. People talking short sentences. Language is getting transformed now. Our original English, for example, now you say FOTO, photo. Sometimes you don't even spell the whole word, right? 5 years later, 10 years later, that's what people will use. And that will become the language at that time. And value. Data, whatever you have to convert that into some value. Without value, data cannot be processed in a digital computer that we have. And few more other issues, semantics, security, and privacy and usability. So you can see there are a whole range of things we have to address with this data. Now, let's talk about where we are today, mostly. Today, we are with the structured data. Structured data means like data in SQL database, structured query language, or MySQL, same thing, right? So, data has no structure. You can go to the table, you can address particular column or row and so on. So, structured data is basically numbers at its core. For example, you can ask how many times a page was visited, right? Or how long someone was on a website, or the click-through rate, CTR. These are all numbers. And we can calculate that very easily. Also, it can do analysis based on counting. And that itself is a huge benefit to the industry. Most of the big companies are making a lot more money than before because they have much better marketing tools. Customer questions and customers' feeling they can understand using just the structured data. For example, how many transactions Amazon does every day, and they need to analyze that. Same is how many times people access Google search engines. How can they improve the search engine and so on. So all these data analysis, how much more money a company can make in the next quarter, what they have to do. All these things come to a major extent with today's numerical data. So this is great already. Now the question is the other side of the coin. This is great as of today. It has been great, but you will be driving the future. So what is in future? It's already here, but it's becoming more important in future. This structured data that I mentioned is is only about 20% of the total data. The rest 80% is text, audio, video, dominates, and hence more important. These have no known structure. So it is not our desire to address the text or unstructured data. These are called unstructured because there is no structure. You cannot put it in a database. It is not only our choice, but it is a requirement. Because if you don't do it, we will be missing 80% of the data on the world. I mean, on the internet and other sources. Counting and number-based approach does not work anymore. And I will show you with an example, a few examples. For example, if you want to count, what type of count you can do for these two? From customer feedbacks in a running test. Customer is saying, this product is good. Another one is saying, this product is good but can be improved, right? If you use today's analytics, today's structured data method, number crunch, right? What can you do? These are not numbers, right? These are all text. These you cannot convert. A human can understand what it says and then convert them into data, but that defeats the purpose because then you are not automating. Same thing from voice recording of customer service transaction. You know, machine cannot, as I mentioned, this computer to play some voice recording from customer. You don't understand anything. It may understand your words, but it will not be able to give you any meaning of those things. How are tweets being interpreted and analyzed? Tweets are text, right? What type of information can be gleaned from customers' product reviews? And same thing goes on and on, right? When customer reviews their videos, what do you do? These are all our data. We need to process them, understand them, and so on. So, addressing this unstructured data, clearly we need to address unstructured data, number one. Number two, we also need to address mixed, meaning structured and unstructured both. For example, if you open up internet or you can say Wall Street Journal, there are a lot of text. Also, there is a tables and numbers. So we need to integrate human. We understand both. We need to process both in the computer. Some companies already are doing it. They already started some text processing with some existing NLP. NLP means natural language processing. So you will see that, you know, they are using traditional NLP algorithms. They are sentence segmentation, tokenization, stemming, meaning finding the root of the word, part of speech tagging, name entity recognition, very important, and parsing and other elements. So some companies are doing mixed text analytics, which is very good, but we need more. So text mining is good, but it is in early stage. Also, type of problems in text mining and meaning unstructured data is different than structured data. For example, let's feel it. SQL query can find desired data from regular transaction-oriented database. That's what we use today. OLAP, online processing, analytic processing, and data mining can be done on data warehouse or data marts. Semantics in structured data can be well defined. You know, in other words, you can do all those things because structured data is a mature field. So mature field is important. It's great from its own perspective, but we need to address, in addition to those, we need to address unstructured. Now, defining semantics is much more difficult. So defining semantics for numerical data in a database is relatively easy, right? But for text data, it's very difficult. The query itself is difficult, and the question mark why means maybe semantics that I explained before. And you can see people are going to ask natural questions. For example, what is the key message from most customers about the customer support experience of company XYZ? Contrast that with this guy. How did the stock of a company XYZ perform during last 3 months? Now this can be done. This can be done with today's machine. Because if you go to company XYZ report, look for the stock, and the data of the stock is in the database table. Take all of them and average and give you some result. Our analytics can do it today. But this one or this one, what can we infer from the e-news about company XYZ during last 3 months? These are not something like stocks that you have in structure data. Everything is run in text. So analytics tool will not be able to do anything today unless we have new analytics tool that can understand mixed data and so on, especially the semantics. Now, let's go a little bit again. I know this is a little busy foil and also probably a small font, so you might not be able to see it. But it's important from the fact that, and I will try to verbalize it, from the fact that we understand where we are. Right? We have done a good job here, making good progress. Sentiment analysis. Best roast chicken in San Francisco. Computer can understand that. It's okay. We can do that. Now let's see where we are, and machine translation too. Google does a great job in doing Chinese to English. But these are all probability based, and there are issues. Probability is great, statistics is great, and I'll come back to it, but there are issues. Now, without going into the details of the issues, let's see what those issues cause us. Because of those issues, we cannot solve this problem. How many students graduated from Mann University in Computer Science in 2015, say fall, or just over 2015? If you type it here on any engine, Google or Bing or whatever, you will get answers like Mann University, Maharishi University of Management, Fairfield, Computer Science, things like that. It will not give you the answer, I can guarantee. And why? It did not understand this unstructured data meaning. It did not understand the question to begin with, let alone figuring out the answer, right? You have to understand the question before you answer. And even if you understood the question, answering would be very difficult, because just to know and go to MOM database, log in, go to the table, structured data, understand the table correctly. Understanding the table correctly is not simple. And then producing the answer in a nice way. Meaning, yes, from MOM in 2015, X number of students graduated. That should be the simple answer, not a bunch of links and other things, and page, so on, right? And that's why it's different. That's why we cannot do all these things are related to semantics that I mentioned. So we need to do semantics. We need to address the problem of semantics, then we can address all this. And this is where the industry is headed. These are good, we have many products, more will come, but if we don't solve this, we'll be stuck. Anyone who will solve this will lead, right? So our goal is, together, let's lead. And so, as you can see, much more complex problems to solve to handle future big data and data science. The key is to use NLP-based computing with a highly capable and efficient semantic engine. And I'll talk about that. That's the main juice, in a sense, of this lecture. Other key areas, of course, we need AI, machine learning, and related advanced algorithms. We need natural language UI, so that whatever you type or say, computer will understand and respond to you with that UI. And effective and efficient integration of all these is complex multidisciplinary area. So academia today, especially computer science, is a highly multidisciplinary area. Okay, and so when you take courses so that it gives you more breadth, so that it helps you more in the industry when you join. You can handle more variety of work or tasks. Now let's get into the semantics, because that's our main goal. That's the core engine. That's where the problem. You can solve it. Everything else is going to be mathematical. Of course, there will be challenges, but still. So context is very important as a human, right? As a human, we understand only based on the context. So here, if you say John writes in a Mustang and John writes on a Mustang, somebody might think that somebody made a typo. I means O, so that can be one choice. Computer might think that way. Or second one is only a horse. If you know the US context, this means Mustang is a horse. Here it's a car. So understanding the context is very important. And for that we need word knowledge. What is word knowledge? Like John writes on a Mustang, is the knowledge that people who were born here and grew up here, they know that meaning. If I say today is hot, that means I meant Fairfield because I am in Fairfield, right? I didn't mean New York or San Francisco or something. Computer doesn't know that. It does not have the word knowledge or the common sense knowledge. And this is another challenge we have to give to computers. So word knowledge is needed to understand semantics. And human brain can understand all these things very easily, as you know. Keyword is not the answer. Today's search, although very great, and I'm getting to that, is not keyword, it is mainly keyword. Semantics using predicate logic, ontology, and the like are good, but not enough. Predicate logic is basically the logic, Boolean logic, and the next step is, instead of Boolean, you do predicate, so you can express something. And in ontology and the like, we define the semantics. And then based on the semantics, you can query something and you can get something out, which is very useful, but not enough for this. For example, let's say Moharani is a restaurant, and we say Moharani serves vegetarian food. So if we do our predicate logic, it will be serves Moharani vegetarian food and restaurant Moharani. So these two statements would represent this knowledge. Now, if you ask, is vegetarian dishes served at Moharani? System will not be able to answer. But, so it has mechanical semantics. If you define what is dishes or what is dish, then it will be able to answer. Meaning that you have to define semantics for every case, which is not possible because there will be combinatorial explosion. Too many choices. So past 50 years, there has been a lot of research on natural language processing, natural language understanding. NLU means natural language understanding. And good progress has been made, but it is mainly to solve small or relatively simpler problems. NLU complexity, is mainly related to four things: abstraction, how you abstract, representation, real meaning, and computational complexity. These are the four things that we need to address the natural language. So that's what we have addressed here in SEBLA, semantic engine using brain-like approach that was mentioned at the beginning during introduction, and also it was in the flyer. and it considers each word as object. What does that mean? Let me give you an example you will understand. When you were a child, your parent told you ball, and you learned ball. How did you learn the ball? At that time you didn't know even how to talk, right? You saw a ball was rolling, bounced back from the wall, came back. So you learn the features of the ball. So if your parent taught you with a black ball and then asked you or gave you a red ball, still you would say it's a ball, because in your mind ball was not the color, ball was something round, something that can roll, something goes to the wall and bounces back, right? So it's the feature that defines the behavior, function that defines the behavior of the word. So if we can consider each word as an object and define those words like those basic features that our brain used during our childhood, then we have a different story. So semantics of a sentence that can be calculated using the semantics of words. That's how we do it in our brain. If you give us sequence of words, then we connect them and understand what we're trying to say, and wait for the next word to understand even more. Semantics of a paragraph is then calculated using the semantics of sentence. And natural semantics as opposed to mechanical semantics, meaning we are not artificially defining semantics for dishes or vegetarian and things like that. So, what are the algorithms? So that was the key algorithms, but next level algorithm is basically we use word features. Those are called word features, as you have seen here. So ball is ball, move, roll, round, play, and blah blah blah. This is where we have to work together. You define and you use machine learning based on the lots of data, natural language data, and improve the learning, because that definition is important. This is showing the word feature table. Okay, so like ball is like that, CD is like that, and sometimes we may not be able to take all of them. We may take important ones depending on whether you are running in a smaller machine or so. So we have the basic idea. For a sentence, it will be like person, go, school, and so on. Now we have to do, I just showed you the basics, not the details yet. That may be another lecture. You have to process, we need to process all these things properly to derive the real meaning from this structural meaning. So, assume that those structural things are done. Now, a Sebla-like full natural language understanding system can do the following: paraphrase and input text, translate the text into another language. We do it today, but the reliability or accuracy will be much more. Answer questions. The question that I mentioned, Mom, how many students graduate? Do summarization and draw inference from the text. Existing NLU methods cannot do all this, mainly because of the natural, lack of natural semantics. But Sebla does this well, and I'm going to show you some results so you have better feeling. Before that, let me show you one application, which is advanced analytics. So today's analytics mainly focus on numbers and give you some result based on the table data and so on, structured database, with some text processing. But with Sebla base, you can ask questions to your analytics. You can ask to give me a summary of today's article, for example. It will be able to do that. So that's advanced analytics. That itself can be a presentation. As I said, I'm just going over the basics today. Now we have seen that with structured and unstructured data and using semantics as the core engine for the unstructured data, we can now do things like I showed you, like advanced analytics, summarization, and so on. But let's now take it from to a different angle. We have seen internet was really born, invented late 60s, but was really born around early 90s, right? When Mosaic was the first browser, you may not have heard about it. Then the real portal started with Yahoo. And it was a portal. Portal means you could get news, weather, horoscope, and things like that. And then they added storage. So internet started with portal, then it went to search, and search was also done by Amazon. Then later on, Google came in and sort of took the whole market because they came up with some good approach, which I will talk a little bit later. Then internet meant transaction, eBay and Amazon. Today internet means Facebook, Twitter, right? I mean others are there, but many, right? What is next? Because we need to know where the internet will go next so that we can address that and solve those problems, right? Well, based on some research and the trend, we see that people will be looking for very specific information and more precise and direct information in a very easy way so that even an illiterate person can do it. For example, today's internet is used by most literate people. If you give it to somebody in the village, they wouldn't know because they don't know even how to read and write. I mean, they know how to read and write, but they can talk and listen, right? So we need to bring internet in a meaningful way to everyone, and this kind of information will be good for everyone. If you today search something, you get millions of hits, right? It would be nice if you get only under 50 or some hits, precise to your answer, precise to your question. So this means that much smaller set of search results instead of millions you want to get something under 100. Answer or small set of answers to your question, not so many answers. Summarization of articles, drawing inference from set of documents, more into these specific requests. For example, send me the picture of last Saturday party, and you'll get all the pictures right away on Facebook screen. That should be helpful, right? So people are busy. We want to automate and make machines more intelligent so that it's more attractive to us because it's going to help us more. And of course, natural language dialogue. So major component of this next generation internet, we call it intelligent internet. Big data and data science handling capability. Today's websites, very static websites. There are some web services and things like that we do great, but in general, websites are not intelligent yet. You cannot query things like that and get results, or the one I mentioned, maybe get results. So we need some intelligent agent sitting on the main website as a server. The client needs to have, some intelligence as well. And it needs to have big data and data science right there, because depending on the application, you want to process everything immediately there. Natural language capability so that you can query and talk in a natural way. Even if you cannot talk, you can type, still people understand and give you the result. And strong relationship with advanced analytics. It needs to have the capability of advanced analytics so that it can absorb all kinds of data and extract meaning out of it. So this is what I'm talking about. There is a main agent, and then you can have supporting agents. Like this agent might be doing e-learning details, and this agent might be doing e-commerce details. And then main agent, there might be more agents. You might be having one agent to just do all kinds of web services to communicate with other similar websites and bring results and so on. So let's look into this in more detail into one example, that is search, because search is very popular to everyone. Let me check the time. I was not. So I have 10 minutes, I guess. I was planning to make it an hour, and my cell phone died, so I could not use my cell phone to see the time, and I don't use a watch. So today's search uses string match and idea is some inverse of frequency and millions of it. For example, if you type auto body shops in San Francisco Bay Area, Google gave me 1.2 million in 45 seconds. Now, there is not probably 1.2 million auto body shops in the world, right? So there is something not right, and I'll get to that. And so there are some key issues. Of course, Google is great, the best search engine. Don't get me wrong, we are talking about the facts and future, right? So, right now, deep semantics you have heard, deep learning, semantic matching of the title with input sentence to derive data. So, what I will show you, we did intelligent search, taking the results from Bing or Google directly, and understand the meaning of every search result, 1.2 million hits for example, and then filter all of them, take the one that makes sense to you based on your research. Okay? So with that, I'm going to jump, I'm not showing this diagram, maybe I should quickly so that you know the algorithm. So we are doing semantic engine does compare the input sentence, and then we figure out which titles or headlines are correct, and then we filter them and give it to you, and we continuously learn over time using machine learning. And Sebla can also do the rendering. Rendering is very important. Rendering means how do you give desired information to the user. If you throw all the pages to the user, that's not good. You have to make the results in a nice way, presentable way that I mentioned before. So that is rendering. Rendering is very important. So you can see we got 46 results. Reduced 1.2 million results to 46 results. And the sentence was not auto body shop. Sentence was low price, high restaurant in Silicon Valley. And you can try it on your own. If you try this, that's what you will get. So this is just a token representation of the advantages of intelligent systems. Intelligent search. We can apply the same thing for Q&A, the same thing for summarization and inference, advanced analytics, and so on. So, similar picture to the one that I started with. AI is driving next phase, right? Here is AI, NLP, machine learning, big data. And you can see man-machine interface is very important because we want to have natural communication. IT, internet, biomedical, energy, modeling, manufacturing, you name it. Everything is controlled here, and you are the driving force for that. That's computer science, right? And for mom, software, our curricula is geared towards software. Also, it's geared toward other things, and I'm going to show you that. One important thing to note here is AI is also key for design for 90%. That means, whatever products you see today, most of the companies design them for top 10 to 15% people in the world because they're the ones who can pay for it. But the world is not only the rich or people who can afford. Most of the people are on the other side of the world, which is called digital divide, or poor, or a little bit better than poor. designing for them is very important. And AI is a big way or best way to design for them. And the multidisciplinary I mentioned before. So, just join us to drive the future. We have a strong team in big data, data science, AI, and machine learning. Several courses for data science and big data. We have big data analytics, algorithms currently offered. And then others, we have machine learning course coming in March 2017. You are welcome to